There's only 5 people.
Okay.
Hello.
So you're behind the scenes for the Hack Chat. We're in Hack Chat. We put all the links everywhere. It's in the description. So as Ladyada is typing in more, you'll see that. We have some fun surprises as we do this Hack Chat.
Indeed.
So y'all can just see this director's cut behind the scenes live as we do this.
Heck, have 2 windows open, one with the chat, one with this video, and you can like stereoscopically hear all about and see all about creative robotics as we get ready to do this Hack Chat.
So while we're doing this, I will play a video. Let's see which one.
Which one? That's good.
Token 5, approach and identify. Master Day, Capricorn 15th, year of the city, 2274. Carousel begins.
Everybody's getting ready to be in the Hack Chat. That was your video.
I'm glad that we went through the process of carousel and regeneration before we begin this chat. Sounds like they're waiting for some people to show up, so we're just gonna keep it chill, hanging out, flying the pirate flag.
That's right. In fact, we'll have our robotic friends say hello real quick too.
Okay.
Welcome to the Hack Chat.
Welcome to the Hack Chat.
And we'll check in with them later and see how they're doing.
Good. They have other things that they may have to, may want to say while we do this chat. We have our robot friends. We're all about robot friends here. Not robot enemies. Not robot steals your lunch from the fridge. Not robot trips you down the stairs. Nope. Only the best friends from Robot Parts. So the Bench Off Bot and Sophie Bot, for those who
and
maybe didn't recognize them because.
And you can go ahead and do that.
Okay.
And then for the folks watching behind the scenes here, we'll talk about how we made these. But our goal was to do a Hello World robot in like 5 minutes, and so these robots take about 5 minutes. Uses open source hardware, open source software. It's Python, and it was a couple lines of code, and then you're able to make a very quick animatronic head.
Yeah.
And so Sophie and Brian sent over some files. We tossed them on there real quick. We're at the Adafruit factory, and so our time constraint really is like, okay, we have 5 minutes to
it's like,
make a robot.
It's like while our code's compiling, quick to the robot station.
Yeah, so she said she can't see. Yeah, she can't see the Sophie bot.
We can skip to the
but I can just go to that and be there the whole time. Yeah.
Welcome to the Hack Chat.
Yeah, so
that's just all Sophie.
And then we have a Hackaday, fun little thing here. You can turn that on.
Okay. This is a really simple one. This is a project Noah and Pedro did.
And so if you press the button.
Oh.
Yay! So you can just, why don't you just leave that over there for now?
Okay. It'll just fall over in about 5 minutes, probably.
Yeah. And let's see what Benchoff had. He sent another WAV file over. So.
Life is suffering, and I intend to suffer greatly.
Oh, Brian. All right.
Life is suffering, and I intend
so
to
that'll
suffer
do random.
greatly.
I have 2 files for him. So we'll continue to check in with our robot co-hosts throughout the show.
Sweet. All right. We'll get started real soon. Robot Roadshow.
Okay, so I think you have to start typing chat. So
okay.
let's do this thing.
Sophie has a question.
Is that distracting to you? Maybe pause it. Yeah. 'Cause this all isn't distracting, so.
Oh, you can switch his direction.
Yeah, of course.
Oh, I didn't know that. So one button goes forward and goes backwards. Great.
All right. You're required in the chat, Ladyada.
I'm gonna take a break here.
I'll click buttons.
Okay. Okay. So Sophie asked, "Who am I?"
Yeah, who are you?
Of course. So I'm the lead engineer and owner of Adafruit. That's our open source software and hardware factory here in New York City. That's
Yeah, some folks think we're in Brooklyn. We were never in Brooklyn. We've always been in Manhattan. We were in
No,
an apartment,
no,
then we
we're
got
in
2
Soho.
apartments, and now we have a real factory.
So the machines are actually running.
Yeah.
You can
Yeah, today's a busy day.
hear them on the live stream. And maybe see some people loading up the feeders. So that's me. I think that's me. And then this is Mr. Ladyada for the people on the show watching
Yeah.
the video.
14 years ago, I started Hackaday, and I made the logo, I made the site, and I'm always happy and pleased to say the folks that run it now are doing a fantastic job, better than I would have been able to do. So thank you, and also thank you for the pin and for the flag. These are I don't have many possessions, but these are special. So thank you, Sophie. Thank you, Brian, who I know who have been working on a lot of things. The Hack Chat was. When I did my Hackaday manifesto when I started, I'm like, it'd be great to have like a weekly chat. It'd be great to have like a post a day. It'd be great to have a comic book. It'd be great to have like all this stuff, and they did it.
Yay!
Yeah.
You have to do some of it.
I'm gonna switch positions of these bots, of the Sophie bots on camera.
Yeah.
Yeah. See,
Switch 'em.
these bots move around.
No, I think Bunchoff's had enough time in the camera. That's it. And also, like, Sophie's got the glasses.
Hello.
Hey.
Yeah. So
Hi.
let's see how they look on the camera.
Okay, so we're here for the next half an hour.
All right.
Hit me up with the cues.
Welcome to the Hack Chat.
All right. Sophie said she was on a bunch of phone calls before the chat, and I said we can fix that. So this works for teleconferencing too.
Yeah.
But I did think I would show like really basic construction, really easy to do.
Yeah, why don't you do that while we're waiting for some questions to pop in?
And put these in. See what Brian has to say about this.
That's a good idea.
Oh, that's a good idea. All right. Thanks,
Okay,
Brian.
thanks. Okay, Sophie asked, give us the lowdown on how Cricut works. Well, since she's an engineer and I'm an engineer, I'm assuming she wants to know the hardware details of what Cricut is. So Cricut actually started as a project called Seesaw. I have to like type and talk at the same time. Basically, you know, we see so many different chips on the market, which is great, but some, like the ESP266, don't have, say, analog in, and some don't have a lot of timers, or PWM like the Raspberry Pi. So I was seeing people want to build, I don't want to say robots, but like animatronics and creative bots, but got hit with, this hardware I'm using doesn't have, 5 PWMs or ADCs or, 5-volt NeoPixel or the ability to drive NeoPixels. So Seesaw is the solution we came up with. It's a I2C to anything converter. Now you can buy I2C converters like ADCs, DACs, PDMs, etc. But by the time you add them all up, it's like $4 bomb. Sucks. Because you're paying $1 for the PWM driver, $1, like $2 for like the ADC and the only 2-channel. It's way cheaper to have a Cortex M0 that has all this stuff for free, and then you just write a transport. So we did. Now we can do robots because I wanted to keep the price low enough that you aren't like spending hundreds of dollars. You can take advantage of Seesaw and then pair it with your fave micro, whether that be ESP82, ESP32, Raspberry, Microbit, Teensy, Feather, etc. Because it's just I2C. And everything ever in the history of everything has I2C master. I'm not even a big fan of the I2C protocol. This is what I'm stuck with. Everyone has I2C. So, so that's what we did. So then, Phil and I went to Dim Sum. And we decided, let's make a robot platform for all his awesome ideas. We literally sketched on a napkin. It was like so out of like some like Silicon Valley like, you know, dream. It was like, ooh, let's have an idea. And came up with the Octagon.
Yeah, and for the folks on camera, one of the constraints that we had is it has to be really low cost, has to be open source. We wanted to use something like Python. Educators had to be able to use something with blocks. Couldn't have downloadable only software. Arduino IDE, for instance, had to be really fast. So we were developing CircuitPython, and you're able to do quick iterations with robotics. The device shows up as a USB drive, so you can literally open up a text file, change something, and that's what we did with this. When I edit code, I just pop it into anything that can look at a text file, and when you hit save on the text file, it's code.py. It restarts, and then all your robots are just working. You don't have to compile something and then download it. So it needed to do all this stuff, and it needs to also work with the Arduino IDE if you wanted, and it also needed to work with a block editor like MakeCode, and it should be able to be programmable with something like JavaScript, and it should work with something like Python. And our favorite editor is Moo. It's a beginner editor, and what we wanted to do is have a hello world, literally for robotics, where you can make a robot wave and say hello world in about 5 minutes. And we have to deliver that to educators for, you know, $50 or less.
Yeah.
You know, and with packs and how we do stuff, it's even lower cost. So that was the biggest challenge, was all these constraints put together.
Okay, so people had some questions, and some people said, some chips don't have I2C, and I'm like, you're purposely picking picks and chips that don't have I2C. Spend a couple more cents, get something with I2C. Pretty much everything now does. It's not 1995 anymore. We have peripherals. Moreover, you're more likely to get something with I2C than with one wire. Like, one wire is definitely too slow. So if you're going to pick a protocol, I2C is the right one. Why? Because robotics doesn't have to be that fast anyways. You know, like you're setting a PWM and the timing stuff's taken care of for you. I have written code for the 12C509.
Bang all the things.
Yes.
So do you want to also program it with Visuino? Yeah, I mean, like, that's why we did this. There's people that are already taking all the things that they like to use as a tool and use this. If you can write to a text file, that's it. And so that's why we like lots of different choices with IDE. Some people, they want really advanced ones. Some people want something they're familiar with. And so for Visuino,
I like having a range. Like, start with MakeCode, it's blocks.
Yeah. Drag
some blocks. Want more? Upgrade to CircuitPython. Now you got like Python power, and then if you're just someone who's like, no, I need to be able to do like intense, you know, Kalman filters, you know, use an Arduino. Okay, so people were asking, okay, so Sophie asked, how do you manage power? Oh my God, the power is the best part. I am so glad you asked. Robotic power is really hard. It's the biggest challenge. Some platforms try to do buck conversion, but I wanted to keep it cheap. Too pricey, and I wasn't so sure buck converters are able to keep up with the super spiky
Welcome to the hack chat.
Welcome
Thanks,
to the
Sophie.
hack chat. That's a good idea.
So I decided to force 5 volts. That's it. Someone is gonna say, I have a pick and I want 12 volts. Nope, not for you. 5 volts only. This covers all servos, DC hobby motors, including popular TT gearbox. There are 5 volt steppers as well. And we use this TI chip. I can't remember the full part number. It's like TPS 6592, etc. something here. And it's actually, it's a new chip and it's awesome. It's cheap, 4 amp current management, E-fuse, so it will cut off if too much current, and also over voltage. The overvolt part is a total pain to manage, but this chip can, whoa, I clicked on the wrong thing. But this chip can take up to 16 volts and will light up an LED to let you know that you've overvolted and it won't pass the current, the high voltage to your Delicatronics. It's a great chip. I found it by accident, and it's a new release from TI. Check it out, because if you have something that's 5 volts up to 4 amps, and you're like, look, I don't want to have like a huge transistor setup with like multiple MOSFETs and then level shifting for the MOSFETs. This chip kind of does the whole thing for you, and it has the built-in FETs too. Amazing. So that's the chip that kind of pulled it together. This is not for copters. I like how this Frank is just like, it doesn't do this thing. It's not for copters. It's
doesn't mean we won't be doing one.
This isn't for bigger robots. Bigger robots also tend to use 12 volt motors. So this is for crafts and creative bots, and it's cheap. Okay. HE Makers asks, oh, I forgot to say, also the motor driver has current limiting on it, so you can stall motors safely. Okay. HE Makers asks, hey, can you explain why you didn't send the 5 volts up into the featherboard? I imagine it has to do with not wanting multiple 3 volt regulators. To hear your thoughts about it. Bill, that is correct. I didn't want to have the 5-volt contention with the USB power. So you can do what you did and grab 5-volt from the NeoPixel terminal block. Sophie asks, is that power chip VGA? Sophie, nope. It's a QFN-ish chip. I can even show it on the overhead if you wanted.
Yeah, let's go to the overhead.
I can show the power section here. This is,
and for the folks watching, we have Circuit Playground Express version, Feather version, Raspberry Pi version, and this is the microbit version.
Zoom in.
And
does not want to zoom. Hold on.
Also, there you
No,
go.
there's sorry.
And then also, of course, we're an open source company, so these files are on GitHub for the Feather and the Circuit Playground one so far.
So this is a polarity protection PFET, and this is that TPS chip, which is so small I can't read the port number. And it just needs 2 resistors to set the voltage level that you want. So I set it to like 5.75 volts. So that keeps everything over here protected, but means you can use a 5-volt power adapter or a couple batteries. I think that's the cue so far. We're doing good. 20 minutes.
Yeah.
Yeah, but this is the
Can we go back to the overhead?
Yeah, I'll just show the variants.
Yeah, someone was asking about a TurtleBot, so I'm like, oh, I think I had a TurtleBot video.
We do have a TurtleBot.
Okay, what were we going to show?
This is the microbit Cricut. So I'm still designing this so you can see like the silk screen is being worked on. But what's nice is it's the same overall design. It's just, I swap, instead of like a Circuit Playground Express, which was the first version, I took out that and put in a microbit slot. So the microbit slots into here, and you get all the servos. You get 4 servos, 4 drives. This is a ULN 2003, 2 DC motors or a stepper, speaker, amplified speaker, NeoPixel level shifted capacitor. Okay, Orlando asked, did I miss the answer for the output current capacity? I think someone said 4 amp in the chat. Orlando, he's into analog. It's 4 amp into, through the power supply total. The motor drivers are 1 amp each limited. And the ULN are 500 milliamp per. Of course, you can't have everything on all at once, but you can pick and choose. For super secret high power, can always backfeed through the NeoPixel port 5-volt 10 amp, but we don't recommend it because you're skipping through the power protection, and that could end badly. Okay, some people asked for the part number for the PMIC, and someone found it and they pasted it. Yeah, the chip has a lot of variants. So check the DS for your desired config. But it's been great. You can really abuse the heck out of it, and that's important for robotics because you will draw more current. You will plug something in backwards. We actually did a project where we tried to power 6 Metal Gear servos at once, and like the PMIC failed, but at least it failed. It didn't like freak out on you. I can also show the a really cool thing with the seesaw.
We're getting that ready. I'm going to check in with our robotic host.
Yeah. Oh, this isn't on.
Welcome to the Hack Chat.
Welcome to the Hack Chat. Life is suffering and I intend to suffer greatly.
Yeah, I don't think this is USB. Can you,
We're going to power you up?
well, I just need a USB port. Micro USB.
Yeah, sure.
That would be cool. I have one, but it's hidden over there.
Yeah.
Another cool thing is the seesaw has a voltage monitor and will. Yeah, can you sorry, can you plug that in really fast?
It's a Cricut or the circuit playground?
The circuit playground. Other way. Oh, perfect. Yeah. Even on. Yeah. And blink the NeoPixel on bad power. Joel says, I downloaded the CircuitPython file for Cricut, but I can't get CircuitPython file to open. Joel, check out our CircuitPython beginner guides on how to install the CircuitPython runtime on your...
Is it the CircuitPython Essentials?
There's one before that. It's the Welcome to CircuitPython guide.
I shall post it in the chat.
Thanks. Okay. And then ATMaker says, if you have the teeny Seesaw board to show, I love that as an RPi add-on. Yeah, we have Seesaw as a separate breakout, but it's not as intense as the SAMD21. Although we do have an upcoming design for a Cricut hat. So, you know, to make it fit on a Raspberry Pi, we kind of hatified it, and, you know, we put the drives and motors and speaker and capacitive touch stuff over here. This is the Seesaw circuit, and this is the power supply. Again, you can see that TPS and the transistor and the two LEDs on off. And it just kind of squished together when we put the servos and signals in the center. Okay, ATMaker Bill Binko asks, can you go over the syncing outputs, voltage how to wire? Yeah, syncing outputs are confusing to beginners. Basically, you cannot send a high voltage out. You can only connect the pin to ground as it were. So if you have a solenoid, connect the 5 volt from the board terminals to one side, and ground would go into one of the ULN 2003s. There are a lot of ULN XXX guys out there, and this is basically identical. Will the Pi Cricut have an EEPROM with DT to configure the RPi IOs at boot? There are no IOs used on the RPi really. It's all through I2C. So you set it up all through Python. But we'll take a look. I've had really mixed experiences with device tree overlays. I sort of prefer a shell script. Yeah, but he asks, like, why not have I2C on? The DTO stuff is just not very well documented. I'd rather have, since you have to install anyways, having a shell script run the rpy config command is easier to debug, understand, improve. All my DTO stuff I've had to revise and update as new pies came out, and stuff changed with Linux. So nobody really uses it except for rpy Foundation, because they dictate the design anyways. Okay. This question came from the live video chat. Do DC motors share power the Cricket? Is it possible to break the connection and power them separately? For DC motors, yeah, it's powered through the Cricket. You can always just connect a DC motor to power, but then you wouldn't be able to control the speeds and direction. So we recommend using the motor ports. There's two. Okay. Somebody asked, will the Pi hat be stackable to add more PWMs for servos over I2C? For more servos on Pi, we really recommend stacking on our servo bonnet or hat. They don't conflict over I2C, and then you get 16 more. Yeah, I mean, I don't really design the Cricket to be stackable, because it's instead of like you get so much that I thought like this is kind of going to get you started, and then if you become like a super robotics expert, that's when you'd say, okay, get the motor hat for 4 DC motors, then stack a servo hat for 16 servo. All that stuff adds up really fast. Before you know it, you're up to like, you know, everything all together is going to be $100.
Yeah.
In order to enable,
there's a lot of $500 robotic kits.
yeah, in order to support the kind of projects that we want to do, we want to have like it's a bento box. You get a little bit of everything. You want the sushi boat? Get the sushi boat. This is like, ooh, I get like you know, the shrimp, like whatever, shumai, and we get some rolls, we get some sushi,
yeah.
We get some seaweed. You get a little bit of everything. You only get 4 capacitive touch. You only get 4 servos. You get 2 DC motors. Not everything.
Yeah, can always do more and add more. We've done that. Like we have a Gemma, or a trinket, really low cost. We're also able to do things that are very advanced with Raspberry Pi, for instance. Like we're working on a giant open source 3D printer controller that's kind of like the Mega, but for the M4, and you can do things like Python on it. So that could do almost anything. And you could run a factory or a quadcopter or a 3D printer. You have a lot of choices, and that's what we wanted to do, is have all the code out there, all the hardware out there, and then depending on what your application is, if you want to do low-cost cardboard robotics, great, we got something that's $20 or so. If you want to do something bigger and better, you can decide what you want to do with that.
Yeah. Okay, Bill asked, will the Cricket hat allow stackable headers? The answer is yes. Our design for hats and stuff now, we use a surface mount 2x20 header on the back, but we leave the holes through, so you can use our 2x20 stacking header. It sticks through, and you just shove the hat or bonnet all the way down, and then you have like the extra pins at the top. Okay, more questions. We got through them so far. We're also at a half an hour.
Those are questions.
Someone asked, why aren't you using SMT headers more often? We have used them in the past, but they I get annoyed with how they bend easily. We have a selective machine, so through hole works really well, and if we can, we prefer them. Okay, what's the coolest thing you've seen made with Cricut so far, or what would you like to see someone make? This is a good one for you. You want to?
Well, I just like that, you know, Ladyada makes platforms and all this code and all this hardware, so we've already seen like a self-balancing bot. The experiments that people got right away going, I like how quickly they can make a car, you know, just like have something move, you know, not spending all the time doing this stuff. So the simple projects, the clever projects that someone can do instantly are my favorite ones. On the advanced side, and we just get to see these things because we watch Twitter and look at all these stuff. There's lots of things like little mini golf courses and games. There's carnival and circusy things. There's lots of interactive games that people can make very easily. There's, of course, animatronics. That's a fun one. I like ones that do things that, because of the assistive technology world, people are like, oh, I'll put neopixels on it, so when things are okay, it's green. When you need to do something, it's red. And that's happens to be good if you're hearing impaired, or it'll vibrate if someone is vision impaired. So I like that it's whatever they want to do really fast, and I think that's one of the neat things when you make electronics, especially the way Ladyada does, is you really don't know what's going to happen. You put it out in the world, and then you're like, wow, that's so clever. I wish we would have thought of that. And some of the projects that we're working on, there was that raccoon that had to crawl up the building. That's a fun thing for kids. So they have little raccoon paws, and the little raccoon goes up, and there's a magnet and a DC motor, and it's very simple to build, but they understand a lot of the concepts, and the code is block-based or it's text, and it's a fun. You can make these out of like paper plates, and you see our co-hosts here. These are a couple Adafruit boxes that we had and just stuff laying around. With a color printer, and we just printed out these things, and so those are the ones that are always surprising. I think the impressive ones that people will be like, oh my gosh, is how quickly and easy it'll be to do like a balancing robot. A lot of people like to do that. We've seen little line robots already. Yeah. So stuff like that. I have like a Etch-a-Sketch. I'm making like a two-stepper Etch-a-Sketch drawing bot, because the Cricut can do two-steppers. So I have a yeah. Hold on, I'm working on. Yeah, when we filmed the Trash Panda game, I got this mask. Okay, thanks, Phil. Keep that on. Yeah. And then while we're putting stuff up for the camera, I pulled the Cricut off this, but this was just like one of the first fun tests. Like, make a robot hand, like, yeah, you know, in a few minutes. So this is the servo that turns. And then one of the other neat things is zoetropes. You spin these around, and you can see animations. This is a painting. I think one of the hardest things about robotics is, you know, we're so trapped in what robotics means that I'm trying to get away from like, oh, have it deliver a beer. You know, like that's every robotics project I ever saw in school was like, okay, cool, now have it fetch you a beer and get it for you. And I'm just like, is this it? Is that what robotics is? Like, it's just so like, it's not interesting to me. Like, that's why I've never done anything with robotics. I've just never been into the like competition. Starbucks salad container, and then you just put a DC motor and Cricut, you can spin and make spin on it. Yeah. So I like this art bots and stuff. And stuff that's like fun, it's useful, it's creative. You know, those Amazon boxes, they're starting to put hashtags in there, like you should make something with it. We didn't see anybody making anything with these boxes, so we're like, great, Trash Panda. A little Trash Panda. Hi. Hey.
Yeah, this is a simple 2-servo.
Amazon Prime delivered Trash
Robot.
Panda.
Are you want to do more?
Well, I was just going to show these very rough.
Yeah, there's no more questions.
The other art box that we really like. So this is one in progress. You know, if you wanted to do an Etch-a-Sketch drawing robot, no problem.
Yes, this is my. You can see I'm starting,
Yeah.
and then you have these servos and you, steppers. You attach them, and then I wrote a G-code interpreter, a G-code decoder in CircuitPython. So it takes G-code commands and draws them. Open loop is fun, but I'm kind of trying to calibrate the Etch-a-Sketch backlash so it can do nice drawings.
Yeah. Also, Hackaday just had the robotics challenge. We looked at. We're like, wow, there's a lot of cool things that people will be able to do or wanted to build, and we have this platform now. Cricut wasn't out during the challenge, but I think you just get ideas from a lot of these things. It's like, I'm like, oh wow, that was like that actuator thing. That's really neat. Like we can do that for like a few dollars in cardboard, and then you can really make it work well with Cricut. You don't have to have a really expensive development board or like a closed source IDE or like all the things that make robotics hard.
Bill asked, anyone know an easy way to convert SVG to G-code? And you saw me like struggle with that for like, that's actually the hardest part of this project. But Inkscape now, if you look at the latest version, has a SVG output. There's just like a lot of steps you have to do. You have to like, set up your tool and you have to like configure it. But once you have it going, it kind of runs pretty easily. Deshipu asks, is Argon going to be smaller versions for some robots?
And we control this.
Plans for smaller robot crickets. The hat is pretty small. Any less and we'd have to drop.
Life is suffering and I intend to suffer greatly.
We have various motor controller wings and breakouts.
Someone did an SVG to code thing. They have to post a good link. I'm gonna say that.
Yeah, there's a bunch. I like Inkscape because you can actually see the toolpath, but it is a little annoying to get going. I think we're heading through. I think we.
Yeah, you got through all the questions.
We got all the questions.
So for the folks who asked what the mechanism is.
Yeah, for the skipping.
Yeah, so this one will be easier to show. So it's a fun trick. So yes, it's vertical. So you think, oh, but a servo goes circular. No, what you do is put a popsicle stick, and you can have the servo go up and down. So I'll put it there, but let me see. So there you go. Now you got vertical motion. And 5-minute build. And this just is sound reactive. And this is Sparky the Blue Smoke Monster. And if you make an electronic mistake, the blue smoke comes out. But Sparky and the, of course you can just toss a WAV file on here and Sparky will be like, it's okay, just add a capacitor next time.
That's another thing. Actually, somebody said, what other hardware did we ask about? One of my favorite things is audio robotics with the WAV playback support in Circuit Pi. It's so easy to make audio playback robots. That's something really hard on most platforms unless you skip to Linux. So that's why I like all of our projects. We finished the robotics and we're like, hey, let's add some background music. When you did the Rob robot controller, we grabbed some audio from a YouTube video and like diced up a little bit, and it had the background music just playing in the background in a loop, and it just like made it way more fun that you have this robot and it's playing.
Yeah. Well,
music.
when I was younger, the dream was like, oh, be an Imagineer at Disney, and there isn't like an Imagineer kit. And if you wanted to do, we're going to do like a Hall of Presidents out of cardboard, it'll be easy to do. And I think it gives, especially young people, a way that they can make those types of things and then imagine themselves having those type of jobs one day where they make robotics. Sometimes there's pop culture things like Westworld, and then there's things that are like, well, I just want to make a cool art robot, or I want to just make something like a claw machine, and it gets really complex and hard. So I think that a lot of the pop culture references that people want to do, like make their own little music video. One of the videos we did was a heart-shaped box, and we took a crow and we made a heart-shaped box, and when you lift it up the box, it plays part of Heart-Shaped Box from Nirvana.
We used the light sensor on the circuit playground to detect when you opened it, and then the neopixels on the circuit playground were did the red pulsing thing, and then it would also play parts of Nirvana. Someone asked, what platforms are you planning to support? Right now we have Circuit Playground and Feather, and the Feather supports 25 different chips. You've got ESP266, Feather, NR52, Arduino, SAMD21, SAMD51, at Mega 328, 324. Maxim has a couple of Feathers as well.
Yeah.
Particle is going to be Feather, so that's like a huge
The Feather
number.
ecosystem is like 150 plus different types and boards, so we have a lot covered. But one of the things that we're doing is, if you know Python, we think we're going to have a robot for you.
Yeah.
It's kind of like, if you're doing any type of Python on hardware, guess what? You're probably going to be able to do robotics. And that's the long-term goal, is to bring robotics to the most amount of people, the lowest possible price. And then, of course, our designs are on GitHub. It's open source. We're interested to see what people do as well. We have like a blimp bot plan. We have, there's all sorts of variations that we can do. The hard part is, how do you get people to learn to be able to program these things? And that's what we've been working on with Circuit Python, and that's what we've been working on with MakeCode. And so you have a lot more choices and options that are really easy to get that 5-minute Hello World robot that will say hi.
Videos with the microbit coming soon, and then sometime in the future, I don't know when we're going to get these out. The microbit, we have to do the MakeCode, and then for the Cricket, we have to do the Circuit Python port. But those are the only plans we have right now, the 4 platforms. But I think that covers a lot.
We did leak that we're doing a gaming platform as well. So imagine being able to write your own games in Python, and maybe that little handheld platform could be used to control robotics too. Okay. So.
Someone asked, does Circuit Python actually support ESP266? We tried Hackathon. Most of the tools it seemed were targeted on something that would actually need a disk drive. That's correct. Sorry, well, it's not correct. We do absolutely support ESP266 as a target, but as you have seen, you need a lot more skill to use it. Moo is not the best tool because you have to use AMPI by hand. Check out, what's it called? It's like can you go to the Essentials Guide or the Basic Guide? It's one, I don't remember the name of this Python editor.
Which one do you want to go?
The guide that you pasted before. Welcome Circuit Python. First link. PyCharm. It has some sort of upload tool built in, but it totally works. I've written code myself on ESP266 Circuit Pi. With so we asked if there's low entry-level graphical setup. The ESP266 doesn't have USB mass storage, so it's not drag and drop. But if you want to contribute a patch to Moo. They love to take PRs and will absolutely integrate it. Okay.
All the crickets are gone. They
Oh,
did
wow.
the giveaway. Wow.
Yep, not having USB native makes that tough. That's why we recommend the SAMD 2151. You get HID mass storage.
Welcome to the hack chat.
Please ask Espressif to add native USB. If they do, we will totally support it. Okay.
One thing I also wanted to mention is First Robotics has so many cool things that they do. I want to talk to them about a First Robotics like Cricut version, so they can do like miniature versions of like the one that puts basketballs in, but for like 20 or 30 bucks. And after school activities where the robots do art, or they're trying to score a basket. We have the little turtle bot that's like those little baby turtles that hatch and they have to get to the ocean before they're eaten or squished. So like racing, stuff like that. One thing that we're probably not going to do a lot of, because that's a different type of market, is things like complex robots that you would normally, like Big Dog, things like that, where it's like, that's obviously an expensive thing. There's vision systems and all that.
Yeah.
We'll probably see some fun things with the Raspberry Pi hack, because you can do vision and stuff like that.
Yeah, what I like is the combination of OpenCV and robotics. Robotics on the Raspberry Pi has been not. There
just needs to be more glue to make this
there's a
go
little bit.
together.
It just needs a little bit more love. I've seen Raspberry Pi robots, but I think and some have used servos and OpenCV, but I think if you have like a wide range of robotic inputs and outputs and sensors, I think you can do a lot more. Okay.
Yeah, there was there's an educator, Matt, that he wants to hear more about these ideas for workshops in classrooms. Yeah, imagine you're trying to do a workshop with 30 kids, and you don't even have 30 computers. How can you do 30 robotics projects? How can you do it for $5 of materials? How can you do stuff? There's always trash around. Every bit of trash, when you look at it, it just kind of it changes your brain a bit. You have a different lens. It's like, that's an amazing container. I can make a cool eyeball thing with that. You can do a lot with a little, and that's kind of what a lot of workshops, a lot of teachers, a lot of hackerspaces, pretty much all of us have to deal with. Is if you had unlimited budget, of course you can get $500 actuators and like do whatever, but you might not be able to have that type of budget or time. So send a note. In our Learn system, we're going to not only have all those types of projects, but we have a lot of authors that are making those types of projects, where it's like, what do you have around the house? What can you do?
Yeah.
In the summertime in New York, there's Starbucks cups everywhere.
I know, we're going to totally get some
Starbucks. Turns out you could put a servo, another cup, and have the inside cup move, and we did a robot like that where the eyes go.
Yeah.
And when you
You
see
want to actually do a drop where you actually left one back in the trash can?
I am going to put robotics around New York City at some point that utilize the trash to show people you can make things out of the trash.
Okay, I think we kind of covered. The people are now chatting amongst themselves, which is good. They're helping each other come up with ideas.
Oh,
and
here's
projects.
there's another one that
Okay.
came in from the other side. I'll put it in. Sorry.
Are there jumpers sending the I2C address of the seesaw on Cricut? Might be some larger projects. We didn't expose I2C address straps because we ran out of pins, but you can recompile the Seesaw core and just change the pound define. It's on GitHub and uses ARM GCC, super easy to build. So if you're doing that kind of stuff, if you're at the state where you're like, I need multiple crickets and they're all gonna be wired together, you're totally the kind of person who is like, I'm going to open up a shell terminal. I'm going to like compile this code. And then you can add and configure and change it as well. I mean, it's all open source. It's all in a pound define and include header file. Is it time for the... It's happening.
Yeah, put that right there.
Okay. Thanks, Sophie. Sophie says, thank you. Oops. Let me see. What's a hack?
The cool thing about trash pots, if you drop them, it's okay.
Okay. Cool. So they did a giveaway.
Yeah.
We have 4 minutes. 4 minutes remaining. Only 5-volt I2C. The question was, is it I2C at 5 volts? Nope, it's 3.3 volt logic. The motor power is 5 volt. Paul says, congrats, Lamore and Phil, great robotics platform. Thanks, Paul. You can even use it with Teensy.
So this has been 30 years in the making. I wanted to show a few things. I'll tell you why. So this is Capsella, and Ladyada got her start maybe with some of these things. And Google it, find it. You can get a bag of these for almost free. It's shipping. And so these you can use with Cricut right now. You can make the floating robot. There's DC motors in there. Everything still works. They stopped making these. The company got sold to another company. But you have to look it up and look at the old videos to understand what these things could do.
My favorite thing about these is there's no firmware, there's no software. It's just like
it doesn't connect to the cloud.
It's a 3-volt DC motor, so you can just like power it. Just like goes
when the
forward
servers
and
are
back.
down, this still works.
Yeah, I can show off one of the motors on the overhead just because they look so cool.
The injection molding is amazing. Imagine all kids having toys like this right now. Imagine them being able to do it for like
so
20 bucks.
You just poke a little like micro banana, little mini banana, here and here. It goes into this like nice chunky DC motor and it still works. Amazing. 30 years later, these things are still running. They're just so simple. I love their simplicity and usability. Somebody asked, is there or will there be a way to program the feather board via wireless BT or Wi-Fi? Just with NRF52, you can use over-the-air with the Nordic over-the-air bootloaders, and of course ESP has their own wireless methods. Just check, the programming language.
Someone asked about encoder support.
And framework.
I'll put that in the chat previously, sorry.
For example, Mongoose or Thread or whatnot. Rotary encoders. Circuit Python 3.0 RC has rotary I/O support. You get up to 8 rotary encoders, all done for you in the background. with interrupts, timers, you just query the, I think, 16-bit
I'm going to play the
incrementer.
bench off lottery here on this because I want to see if he's going to say it's a good idea or if he's going to suffer.
That's a good idea.
Yay!
Welcome to the Hack Chat.
Seesaw does not, at this time, support encoders because we wanted to release, but it's super easy to upgrade Seesaw. It has a UF2 bootloader, so we may in the future add rotary management over the signal I/O for up to 4 rotaries. Or motor encoders. We wanted to get the platform and libraries done first. Okay.
Alright. We showed a lot of stuff.
We're at 401.
Yeah. We showed a ton of stuff.
I think I really did ask them. So does Cricket's with them? Cricket does not.
We still have to work and make all the stuff in the Adafruit factory.
Feather does.
So I have to put all the stuff away soon.
Just use the native IO.
Let's see if there's anything else.
Welcome to the Hack Chat.
And then for the folks that are watching the video, when the hack chat's over, I'm going to play Cricket controlling the Rob, the Nintendo robot. So we use the IR signal from Circuit Playground and Circuit Python. And this is an old robot. You can get these on eBay for pretty cheap too. And picked up spinning tops and stuff like that. And I'll also play the collapsible house and maybe a couple other little videos that I have just to show you. These are, it's like, think of it like the skate park. Everyone's kind of doing tricks and they're like, oh, that was a cool 360, I'm going to do 720. So making these robot projects like, oh, that was a neat technique. And then each person building on top of them and then sharing them. And that's why this hack chat was fun to do. A lot of the ideas that folks had, like, oh, could you do this, could you do that?
Especially with Circuit Playground Express, pairing those together, because you get the robotics on the Cricket. The Circuit Playground gives you the NeoPixels, the sensors, the light sensor, temperature, infrared in-out, motion, accelerometer. You know, you put those together and now it's like, okay, you've got the sensors of the Circuit Playground Express, you know, the buzzer and all that, and then the robotics. There's no intersection. Like, I purposefully made it so they are completely separate. Like, there isn't one thing that they both really do. Other than capacitive touch, but capacitive touch is free.
Yeah, so I made a joke in the YouTube chat. Like, I have jobs besides live streaming. Yeah, we're not YouTube personalities. We work here.
I have to go back and do hardware. I have to
yeah, Ladyada will now be doing CAD, and I will be in spreadsheets and meetings, and we have all sorts of fun. I have we have all company meetings.
Circuit Python, and we're starting the RC 3.0 RC is finishing, so we're starting the process of getting ready for the next push, which is the NRF 52840, a Nordic chip that has native USB. See, if people add native USB, we'll totally support it. But like, man, like if you don't have native USB, it's really hard. It's really hard to bit bang USB for mass storage. You can do it for HID, maybe with CDC, but mass storage, you're not gonna have a good time. So, but that's coming along, and we should put some Crickets in stock. So if people want to pick one up, we have them. If you don't even want to use it with a Feather or Circuit Playground, you don't have to. It's I2C. You can use anything you want. Just like connect the 3 or 4 wires for ground, I2C clock, I2C data, and then 3.3 volts if you want to power it from the Cricket.
One thing I should mention too, I was in 4-H as a kid, and for the folks who don't know what 4-H is, it's normally associated with like agriculture. They do science and coding and astronomy and ag tech, IoT, industrial IoT. That's what it really is now. And a lot of the soil moisture projects that were hard to do before, plant watering, solar, sensor. We did a whole series of plotting data inside of Moo. You can also use Adafruit.io. So we look at that type of curriculum, and if you're teaching things like that, Cricut was made from the start to work with those types of curriculums. So that's really helpful too, where you might have an entire classroom, you're like, well, how do you sense how much moisture is in the soil and how do you water it? Like, that's an interesting experience that people could have. It's not just teaching robotics, it's an experience like, oh, like here's all the things. And one of the cool things about robotics that I read a little like robot manifesto, like how could teaching robotics bring in more people? It's the experiences. Every robotic project that anyone does, you're working on solutions for problems you don't even know you have yet, because the real world is it's not a private universe that you get with code. It's the world, and that's why these trash robots are fun to make, because they have to adapt, you have to glue it different, you have to do different things, and the experience of doing that problem solving, especially not being scared to break it, and knowing it works, you're not waiting for something to compile and download every minute and spending hours just getting the code on something. You can do more with less and be able to empower, especially young people, problem solving, because the soil, moisture, water, something, they start to imagine these things connecting together physically, the code that can glue it together, and then they're using real-world sensors solving real-world problems, but you could do this in a classroom setting for like 30 people. So that's some of the stuff you'll see from Cricut soon. There's lots of youth organizations where they're trying to figure out ways to teach code. It's a little bit easier when you have physical things that go along with it.
Okay. We're just talking about USB Chapter 9. Robotics day.
It's all robotics all the time. Okay, I think.
Yeah, we're just noodling around talking about USB.
I'll keep the camera on until they tell us to stop.
Okay, yeah, sure, whatever. I'm here.
I'm here all week.
Welcome to the Hack Chat.
Well,
these are our best.
You know, the other thing. So Mystery Science
Welcome
Theater
to the Hack Chat.
3000 is a fun thing. Someone already built Crow and Tom Servo with Cricut, and these kind of remind me of that. These are our co-hosts of Hack Chat. It's Sophie and Brian. And I thought that maybe we can add some more of our friends from different community sites like Hackaday to the shows. It's like, hey, what do you think? And they could control the bots from wherever they are. So it's telepresence that you get to make.
Yeah, maybe this weekend. What I'm working on is the CircuitPython layer for Python. So you can install it via pip and then run CircuitPython code in Python. One of my big plans for CircuitPython is it's not just a programming language; it's actually a hardware API written by people who do hardware. Because I was looking at for example, doing I2C on Linux. Whoever wrote the standard I2C protocol, SMBus, never really did a lot of hardware. Did an excellent job that covers 90% of I2C devices that use SMBus, but there's a ton that don't, and that stuff just isn't really, it's not exposed in a nice way. So I think kind of trying to say, look, there's no Python API for hardware. There's a C API for hardware. It's Arduino. Is it the best? No, but that's what we got. Analog write. You're stuck with it. It's PWM sometimes. But for Python there isn't. Once I do that, then the Cricut hat will just work because I'll be able to reuse my CircuitPython library. I just don't want to maintain two libraries at the same time.
So I'm going to cut our audio, and I'm going to play these videos as we wrap up in Tech Chats. Thank you, everyone. Thank you, Sophie Bryan and the entire Hackaday crew, Supply Frame, who I think most people know that's part of Hackaday. All the Adafruit team members here and remote that help out all the time. All of the folks who, of course, support a 100% loan-free, venture capital-free, woman-owned company that does open source software and hardware. I know there's lots of things in the news about manufacturing and tariffs and everything. The best thing anyone can do if you like to see things like Adafruit, and you like to see things like Hackaday, is show your support. There's lots of things that everyone can do. Let's keep this going, sharing. We'll chat with Sophie. Maybe we'll do another hack chat in a few months if they have some topics that Ladyada wants to do. Or we did a CircuitPython chat in the past. We're always up for it. It's cool. When I started Hackaday, this chat thing and the things that the Hackaday team does, it's cool to watch all of it not only continue but come to life. The events, the Hackaday Prize. I like all the assistive technology stuff. So yeah, thanks everyone who works on this. I know it's hard work every single day. Sometimes it's thankless, but thank you. It is appreciated.
All right.
So I'm going to play us out with some cool
Okay, we're playing us out.
robot. Well, we're in the text chat, but
We're in the text chat, but
Bye,
visually,
everybody.
you shall not see me until next week.
we're going to go back to work.
Bye. Hey, little piggy, let me in, or I'll huff and I'll puff and I'll blow your house down.